Okay, so I'm a Mars geologist by background, and my research is on Mars. So you can't get away without having an update on at least the two rovers that are operating, and I think all of our regulars have come to expect this. So the Mars Exploration Rover Opportunity is today is the 4,400th and 19th day, Martian day since landing. And for the new ones of you in the audience, when I say a sol, that's a solar day. A day on Mars is 24 hours and 37 minutes long. So it gets very confusing if we're calling it just a day. Are we talking Earth days, Mars days? So we call it a sol. And if you weren't aware of this, these missions landed in January of 2004. They were intended to last for 90 sols. And so it's far exceeded its warranty. So just a quick refresher here of what Opportunity has done. It landed up here in January of 2004, and it's been driving ever since. It has tended to stop at craters and use the crater as a way to look under the surface. And so nature provides us this nice mechanism of digging holes in the ground, and that means our spacecraft don't have to do it themselves. So it's driven about 45 kilometers so far, and it's been sitting in this area called Marathon Valley, which is on the edge of this 20-kilometer diameter impact crater. So that's roughly the size of the Denver metro area. It's a fairly large hole in the ground. But what led them to this area called Marathon Valley is from orbit, the spacecraft with spectrometers have detected clay minerals near the surface or on the surface in this area. Clays are the type of mineral that is formed when you have water seeping into the rock. The water alters the minerals, and since the whole purpose of this mission is really to follow the water story on Mars, determine when was water there, how long was it there, how did it alter the surface, that was a primary target. And so here's the inside of the crater. This is the crater rim. This is Marathon Valley. And I'll zoom in on this area right here, and you'll be able to see the zigzags that it's been driving around for well over the last year. And so right now it's sitting right here, and they have decided that they're finishing up after all this time in Marathon Valley. And so the expectation is within the next month, they're going to exit and continue on around the rim and just keep examining interesting rocks and interesting locales. And so this is sort of what Opportunity's been up to. This was taken several months ago, but this is a view of this ridge of bedrock where they think this is some of that clay exposure. Here's the robot arm with its drill on the end, and it's got a spectrometer that it can put down on the surface and determine roughly what the mineral content of the surface is. This was nice a couple months ago. There's a dust devil crossing inside Endeavour Crater. And these were one of the surprises of this mission. That 90-day expected lifetime was based on the fact that this is a solar-powered spacecraft. And they knew from past experience that there's a lot of dust in the Martian atmosphere. It settles out of the atmosphere, collects on the solar panels, and eventually you block enough of the power output that you can't keep the rover operating. And the expectation was they'd lose about 0.5% of the power output per day. And so 90 days was about where that was sort of the critical threshold. Every year, several times a year, they get to the critical point and then something blows the dust away. And it's like the Martians are coming out at night with their little dust claws. But in fact, what they've discovered is there's lots of these dust devils in both of the locations of the two landers. There was a twin for Opportunity, Spirit, which expired about 4 years ago. But that's a nice thing to know about now. I'm not sure moving forward, if we land solar-powered spacecraft there, that we will be able to count on dust devils, but so far it's worked for these two. So this is the view of where they have been. So this is the inside of Marathon Valley. This is the inside of Endeavour Crater off in the distance. And here's where they were yesterday. So again, here's the rim of Marathon Valley and the interior of the crater. By the way, for the new ones of you in the audience, NASA has a wonderful website you can go to. It's called mars.jpl.nasa.gov, and I'll tell you this again later. But if you go there, you can go to all of the various Mars missions. Every single day for these rovers, when the new data come back, they're all loaded onto the website, and you can follow along with the, looking over the shoulders of the rovers. So you'll have a bit of catching up to do. They organize it day by day, but it's sort of exciting when you know that something has happened. You can go back and look a few days or weeks earlier and actually see the images of it. And so here's our recap. Again, it's day 4419. So far it's driven, this is about 25 miles, so 42.81 kilometers. Again, the original mission, they wanted it to drive 1 kilometer. So that's been exceeded. And here's our count of images from the various cameras. The image requirement for the mission was 1,000. So again, it's done very well. So on the other side of the planet is the newest rover, Curiosity. Curiosity landed in August of 2012, and it's got some catching up to do on the time, but this is sort of a selfie that the rover took of itself. It's got a camera on the end of its robot arm, and so it can swing it out in front of the rover and sort of take its own picture. And I mean, this is a few hundred pictures that are stitched together. But the difference on this is it is not solar powered. It is powered by plutonium. It's called a radioisotope thermoelectric generator. So they can run indefinitely. Well, indefinitely as long as the plutonium hasn't decayed away, but it's got an expected lifetime for useful power output of about 15 years. And so it's, we're 4 years into this mission roughly, so it's got a ways to go. And so just to set the scene here, the landing site for Curiosity was this area called Gale Crater. This is about a 100-kilometer diameter impact crater. Here's the area that the targeted landing site was. And what's exciting about this location is this big mound in the middle. This is what's called Mount Sharp. And from orbit, people had studied this for quite a few years. That mountain is about 5 kilometers high, so 18,000 feet roughly. And it's made out of layered sedimentary rocks. The puzzling thing about it is the top of this mountain is actually higher than the rim of the crater. And that's really hard to understand because you'd assume that you had an existing surface. You make this big crater, and you're not going to, raise the mountain up to be higher than what the surface started out as. So the thinking is that there must have been a lot of probably water activity in this area, or that was the hope that they could prove that. And you do see things like this, which look like riverbeds flowing into the crater. So it's entirely possible that after this crater was formed, this was a lake, back when Mars actually had a lot more water and that it was possible to have liquid water. So the idea was land the rover near the base of that mountain and make it close enough that over the course of a number of years it could climb at least partway up the side of the mountain. And it has the type of instruments on board where it can determine the chemistry of the rocks and, more importantly, for this purpose, determine what the environment of Mars was like when those rocks were laid down. And so I expect many of you have seen, if not hiked across the Grand Canyon, you know that the old rocks are on the bottom. It gets younger as you get nearer the top. And so by being able to climb partway up that mountain, you're going to get a history of what the environment of Mars was like. And the underlying purpose here is to determine if that environment could have supported life back when there was liquid water. And so here's from the landing site. There's Mount Sharp off in the distance. And there's a closer up view. So this is, you know, what's ahead of them. And you see all these beautiful layers. So there's a lot of things to do in this area. And this is a view from orbit showing their path so far. So here's where they landed. Mount Sharp is down here. This dark stuff is sand dunes. And it looks like the sand dunes are actually 100 meters or so thick in places. So that's a lot of sand. It's like Great Sand Dunes in southern Colorado. And so they did not want to do this and try and just cut straight across the dunes. The assumption was they'd get stuck, and in fact they probably would have. And so they've been paralleling the dunes, stopping at interesting spots, sampling the rocks, until they get down here, and then that gives them their pathway to the foothills of the mountain. And so this is a view I'll zoom in on. Let me back up a second. So this, what I'm going to show you is this area of sand dunes right here. And so there's those dunes. You probably can't see this little line, but sorry, that's not good. Okay. Let's try this again. There we go. So here's where Curiosity is sitting today. And so the yellow line is the path that's actually taken. The blue dotted line is sort of the planned path for the next few weeks. And so they're approaching where they'll be able to break through these dunes. So here's a quick update from the rover
I'm Ashwin Vasavia,
drivers.
project scientist for the Mars Science Laboratory, and this is your Curiosity rover report.
Sean,
Curiosity has completed its second Mars year at Gale Crater. I know what you're thinking. Didn't Curiosity land 4 years ago in August 2012? Well, those were Earth years. Since Mars is farther from the Sun, it takes nearly twice as long to make one circle around the Sun. Each Mars year lasts 687 Earth days. Even though Curiosity may be better known for driving around and drilling into rocks, it has quietly been compiling a comprehensive almanac of the Martian weather. For 2 full seasonal cycles, scientists can figure out which events occur year after year and which ones are unique. Mars has seasons, just like Earth. The similar tilts of Earth and Mars give both planets a yearly rhythm of seasons: spring, summer, fall, and winter. But there are some big differences. Temperatures in Los Angeles are pretty warm all year long, and they don't vary much between daytime and nighttime. But Mars is much further from the Sun and has a very thin atmosphere, so temperatures at Gale Crater are really cold. In the middle of summer, they're almost bearable for us human beings. But in the middle of winter and at night, they reach minus 130 degrees Fahrenheit, or minus 90 Celsius. Curiosity has measured water content and relative humidity over the Martian seasons. Even with this tiny amount of water, if temperatures get cold enough, the relative humidity goes up, and you can get clouds on the sky and frost on the ground. In the middle of winter and at night, relative humidities can reach as high as 70%. but so far, Curiosity has not detected any frost. Curiosity's long seasonal record also has given scientists some new clues to understanding methane in the Martian atmosphere. Curiosity saw a large spike in methane during its first year on Mars. It didn't repeat the next year, so we can rule out a seasonal cause. But there is a lower, background level of methane that does seem to vary with the seasons. Methane may be produced by microbes, but may also result from a number of non-biological processes. Other seasonal patterns have now become apparent as well. For example, spring and summer at Gale Crater are dusty, but in the fall and winter, the air gets remarkably clear. It's been a great 2 Martian years, and here's looking forward to a third. I'm Ashwin Vasavada, and this has been your Curiosity Rover Report. Please check back for more updates.
Okay, so again, let's look at a few of these images. This is a view from Curiosity, about 100 days ago or so. And it's looking at the rim of Gale Crater that's about 15, 20 kilometers away. And I think the thing to notice is as you get farther and farther away, it gets more and more dusty. And of course, what you're looking through is a relatively constant amount of dust in the atmosphere, but the farther you have to look, the more dust is in the way. And so the far crater rim is obscured by the dust. And a couple of new results have been released just this month. One is this was, I think it was in 2014 when the rover stopped and dug some rocks. They're just now getting the complete analysis done, but they found a mineral called tridymite. And that was an unexpected thing to see on Mars. It's a volcanic mineral, and it's the type of mineral that you see in what's called a silicic volcano, something like Mount St. Helens, a very explosive volcano, as opposed to something like Hawaii, a basaltic volcano. And that's the type of thing that requires a lot of heat, and it's very high in silica. So the thinking is that elsewhere in Gale Crater, there's an exposure of this volcanic material in the course of the crater being eroded over the years. Pieces of this mineral got washed downstream and got incorporated in the sandstone that they've been studying. But that's not the type of volcanism that we've ever seen on Mars or anywhere else in the solar system other than the Earth. So that's an intriguing result. And then this was just released in the last week or so. Back in 2014, again, they collected some samples and they've done the analysis on it now and discovered that there's a high abundance of manganese oxides in some of these rocks. And this is the type of stuff that implies, first of all, that there was a lot of water. This forms on the Earth in very wet conditions, but it also forms when you've got a lot of oxygen in the atmosphere. And that's not the case for Mars currently. We didn't think it was the case in the past, but what that says is that at least when this rock was formed, there must have been very oxygen-rich atmosphere, much higher pressure than what we're seeing right now, and it was in contact with water. So another intriguing result. And then the final thing is about a year ago, there was a release from NASA where this is the rim of a crater. Again, this is the bottom here. It's higher up here. But you see all these dark streaks. And they've got some good observations now that these streaks change over the course of the Martian year. And what the thinking is that there's actually condensation of water from the atmosphere, not rain, but it's like dew forming on the surface. And eventually, it's a very salty material, and so the freezing point is depressed, so it can stay liquid. And when you get enough of it, it starts running downhill, and it sort of leaves a wet spot on the side of the crater. They've found a couple of these streaks on Mount Sharp in Gale Crater, and They think that when they get in, there's various positions they could be in as they're climbing the mountain, where using the telephoto lenses on the rover, they'll actually be able to see these from several kilometers away and monitor them to see if they're changing over the course of the year. They are not going to be allowed to actually drive up to one, even if it was accessible. There's a person in NASA called the Planetary Protection Officer, and it's not to protect us from the planets, it's to protect the planets from our spacecraft. So the idea is Curiosity was sterilized pretty well, but the expectation is still that there are some microbes that have survived on the spacecraft. What you don't want to do is get those microbes in a nice environment where maybe they'll start growing. The worst nightmare of any Mars scientist is we finally get to bring a sample back from Mars. We say, yay, there's bacteria in this stuff, and it turns out that it's E. coli, and we brought it along ourselves, and we don't want to contaminate the planet. So they're not going to be able to drive within closer than a couple kilometers if they can actually see one of these things. But that's the next plan, is as they start climbing the foothills, they are going to add this as one of the requirements of the mission, is to try and look at these slope streaks. Okay, so just to get up to date, this was an image that was returned yesterday, and here's where they're sitting right now, and sort of looks like the desert Southwest for sure. So here's the recap. Again, it's day 1386. It's driven about a third of the, about a third of the distance that Opportunity has, but it's returned a lot of good images.